In the world of electronics, understanding complex circuits can be a daunting task. That is where Thevenin comes in handy. In 1883, Leon Thevenin, a French electrical engineer, came up with the Thevenin Theorem, which states that any linear electrical network can be reduced to a simple equivalent circuit, consisting of a single voltage source in series with a single resistor. This process simplifies circuits into a much more manageable form. To find the Thevenin equivalent, we follow a few steps. First, we need to find the Thevenin voltage. This is done by removing the load from the circuit. The Thevenin voltage is the open circuit voltage across the terminals where the load was connected. Next, we need to find the Thevenin resistance. Replace all voltage sources with short circuits and all current sources with open circuits. The Thevenin resistance is the equivalent resistance looking into the terminals. After obtaining the Thevenin voltage and resistance, connect the Thevenin voltage source in series with the Thevenin resistance and the load resistor. This is the Thevenin equivalent circuit. Let's see how this works with a practical example. Consider this circuit with multiple resistors and a voltage source. The aim is to find the current flowing through the load resistor on the right. Following the steps outlined above, we first need to find the Thevenin voltage, which is the open circuit voltage across the terminals of the load resistor. In this case, we can see that it is the same as the voltage across resistor R2. Using the voltage divider rule, substituting numbers in, we can calculate ETH to be 2.5 volts. Let's put this result to the side. Next, the Thevenin resistance can be found by replacing this voltage source with a short circuit. From this, we can see that R1 is parallel to R2, which is both in series with R3. Using the parallel and series resistance formulas, the Thevenin resistance can be calculated, yielding a result of 210 ohms. Now that we have both ETH and RTH, the final Thevenin equivalent for the circuit can be constructed just like this. Using this circuit, the current flowing through the load resistor can be calculated using Ohm's law. The final result comes out to be 4.63 milliamps. The Thevenin voltage can be verified experimentally. First, construct the circuit on a breadboard, and then remove the load resistor, and then measure the voltage across the terminals with a multimeter. This is your Thevenin voltage. A slight discrepancy can be observed here, which is most likely caused by imperfections in the equipment used. All in all, the Thevenin theorem is a powerful and very useful tool for electrical engineers to analyze and understand complex electrical circuits. Thank you so much for watching, and I hope you learned something genuinely useful today.